Today we're going to talk about polar and rectangular forms of equations. And we're going to go ahead and talk about how you convert from polar coordinates to rectangular coordinates. And so up here on the board, you're going to notice here are some conversions. And we're going to do the other conversions too, but this one is you are given r and theta. You want to find x and y. So you're given the radius and you're given an angle, and you want to find what specific point is located there. And so how you can convert is x is equivalent to r cosine theta and y is equivalent to r sine theta. And this goes back into our trig stuff. This is stuff we covered when we were doing trig in terms of the definition of sine and cosine. So that should be nothing new. That's just the thing you need to remember though. X is r cosine theta. Y is r times the sine of theta. And now we're going to go ahead and look at an example of how you convert from polar coordinates to rectangular coordinates. Pretty straightforward. And so, let's go ahead and look at this. It says find the rectangular coordinates for each point with the given polar coordinates. So the very first thing what you're going to want to do is you're going to want to locate where in fact this point is. And so if I were to graph the point 4 pi over 6, 4 pi over 6, which of these 4 quadrants would 4 pi over 6 be? 1. The reason why it's 1 is because pi over 6 is located in quadrant 1, remember? Pi over 6 is 30 degrees. And so that means that I'm going to have like 30 degrees here. And then this is going to have a radius of 4. So I want to find now what in fact are the x and y coordinates for that. And to find the x and y coordinates for that, x is going to equal 4 times the cosine of pi over 6. And y is going to equal 4 times the sine of pi over 6. Now you're going to notice pi over 6 is a special angle. Whenever you have those special angles, you need to use your pink sheets. Okay, so you can never answer decimals if you have a special angle. So on your pink sheet, what is the cosine of pi over 6? Root 3 over 2. So really, my x-coordinate then is what, folks? 2 root 3. Okay, because you can cancel out your 4 and your 2. Now we're going to do the same thing with the sine of pi over 6. What's the sine of pi over 6? 1/2. So what is my y-coordinate here? 2. So my ordered pair will be 2 root 3, comma 2. So let's think about what that means. What that means is that this point, if I were going to give it an x-coordinate, the x-coordinate would be 2 root 3. If I were giving it a y-coordinate, the y-coordinate would be 2. So essentially, you've got a right triangle there. Your x-coordinate is 2 root 3, your y-coordinate is 2.
Oh, so polar coordinates are the ones on the circle graph?
Yes, the polar coordinates are the ones on that circle graph, if you remember. And you can graph those like what I just did to start with. So let's go ahead and look at another one. -2, 135. Now, remember what I said. We always want to start with the visual first. That visual is huge. Huge. Okay, so 135 degrees would be in what quadrant? 2. So here's where 135 is. The problem is that I don't want +2, 135. I want -2. So in what quadrant will the -2 be? 4. So this is actually going to be where your point is located. Now that's going to take into, when we go and solve this for x and y, we'll take that into account. So x we know is -2 cosine of 135. And y will be -2 sine of 135. So all I need to do is plug in what I know. I know that cosine of 135 is what? Cosine of 135? So if I take that times -2, what do I end up getting? root 2. Okay. So sine of 135 is root 2 over 2. If I take that times negative 2, what do I get? Negative root 2. So according to this, my point should be located at, try that one again, root 2 comma negative root 2. Let's look, do my signs match up with where it's located? This needs to be positive root 2, it is, and this needs to be negative root 2. So the points match up, we're good, we don't need to make any adjustments. Questions? Let's look at another one. Okay, 3, negative 120. Very first thing we need to do is figure out where are we at. So what do we do with the negative angle? What does it mean we do? You go backwards. So really, it's going to be down here. Okay, so this is actually going to be 120 degrees. So what quadrant will my point be in? 3. So to find x, I take 3 times the cosine of negative 120. Now the problem is that your pink sheet doesn't have the negatives. So there are 2 ways to do this. One, we can use positive 120 and just adjust the positive and negative signs. Okay? Or we could use this angle right here. Yep, because that's a coterminal angle. So it's whatever you want to do. Do you want to use the positive 120 or do you want to use the purple angle? What will the purple angle be? 240. Okay. So now instead of 120, I'm going to use 240. So I've got 3 times, what's the cosine of 240? Negative 1/2, yep. So my x-coordinate is negative 3 over 2. Now I've got to do the same thing with y. Y is going to equal 3 times the sine of 240. What's the sine of 240? Sine of 240? Negative root 3 over 2. Good. So your y-coordinate is negative 3 root 3 over 2. So our ordered pair really should be negative 3/2 and negative 3 root 3 over 2. Does that match up with the point that should be in quadrant 3? 2 negatives. Yep. So there you go. We'll make that 2 a little bit better. So you think you can handle that, converting from polar to rectangular? I think I might have one more, and we'll see if we need to go over it. You think we need to go over that one? That's a double one? Let's look at this one. There's a reason why. It's not going to take us that long. Negative 120 puts me right here. Okay, the problem is that where does the negative 6 put me? The negative 6 puts me up here. Now this is where the issue becomes. What angle do you use? So what angle do I use? If I use this angle right here, what would it be?
No, it's 60.
Why is it 60?
Because half of 360 is 180.
Yeah, because you've got a straight line here. The reason why it is 180 is you've got a straight line here, folks. That's 180 degrees. You've already used 120, so that's got to be 60. Okay, you only have to do this angle thing when it's a negative angle. So in this case, I've got x equals 6 times the cosine of 60, and I've got 6 times the sine of 60. Can somebody tell me why I didn't use the negative 6? Yeah, I'm in quadrant 1 and I'm using 60 degrees. So the reason why I used a positive 6 is because this is in fact a positive radius here. So what is the cosine of 60? What's the cosine of 60? 1/2, so what is your x-coordinate? 3. What's the sine of 60? Root 3 over 2. So what's your y coordinate? 3 root 3. So your point should be 3 root 3. Best advice I can give you is you've got to plot the point. You've got to plot that point to start with. And that will actually help you, especially when we get into the next conversion, which are rectangular to polar. Okay. Rectangular to polar, this means we're given x, y, and we want to go to r theta. Now it's really important that you get this down. R equals the square root of x squared plus y squared, which is nothing more than the Pythagorean theorem. You have distance formula, same thing. And then theta equals the inverse tangent of y over x. Now, what might end up happening is when we actually do this, you might not even use these formulas. You might use a visual, which is what we're going to start with, and then based on the visual, you might be able to just solve the problem too. So this will be something, if formulas just aren't your bag, that's fine. We can go ahead and when we draw it out, you'll see, oh, that's easy. Not too bad. Okay, so on this problem, I'm going to be given a point. And so in this case, I'm given the point negative 3, 6. So the very first thing what I'm going to do is I'm going to plot that point. What quadrant will it be in? 2. So my point, negative 3, 6. Here's negative 3. This is going to be 6. So I want to find what is going to be my radius. So to find my radius, what I'm going to do, I'm going to go ahead, and make a right triangle here. And I'm trying to find this right here. I'm going to try and find the angle as well as the length of the blue segment. So to find the length of the blue segment, this is where that r comes in. R equals the square root of, in this case, negative 3 squared plus 6 squared. It's just the Pythagorean theorem. That's all it is. So I know that negative 3 squared is 9, 6 squared is 36. So my radius is root 45. What's root 45 approximately? Two decimals. 6.71. So now that's what my radius is. Now I need to find my angle. So to find my angle, I'm going to go ahead and find this angle right here. So to find that angle, that's just going to be the inverse tangent of 6 over 3. Or in this case, it'd just be the inverse tangent of 2. There's a reason why I'm not using the negative 3. You'll see why. So what is the inverse tangent of 2? What'd you get? What? 63.43 degrees. Now that means this green angle is 63.43. So how do you find the blue angle? You subtract it from 180. So I'm going to take 180 minus 63.43 degrees, and my point will be 116.57. So my final answer is going to take the form 6.71, comma, 116.57 degrees. And there you go. But I think the visual helps a little better than if you would just use the formulas. So let's go ahead and look at another one. I have another 1 or 2. So we have 1 root 3. First thing, what quadrant are we in? 1. So I've got a side length here of 1. I've got another length here of root 3. So what I need to do is I need to find this distance here, and I need to find this here. Now, let's think about things. We shouldn't need to use the formulas. What's your radius going to be? What's your radius gonna be?
2. Oh, it is. 2.
This is a special triangle. 1 root 3. So my radius is 2. Okay, now I need to find my angle. What angle is that going to be? Now for those of you that are kind of wondering, what does she mean, what angle? This actually resembles a 30, 60, 90 triangle. Everything is just doubled, right? And so what would this angle be? It's opposite the root 3 over 2. 60. So if you're doing a problem like this and you recognize those numbers, you might not have to do a whole lot of work anyway. You might just be able to go ahead and utilize what we already know. Questions? So we've converted from polar to rectangular and rectangular to polar. Okay, and here's your assignment. Now we actually split this up. I was going to look at a little bit more today, but for right now, I need you to do page 557, 2 through 24 to the evens, and we will add to this tomorrow.